Welcome to Ray for Beginners, Distributed Machine Learning Made Easy. Today, we'll explore how to leverage Ray's features for simplifying distributed machine learning tasks, equipping you with essential skills for efficient model training.
Did you know that over 80% of large-scale machine learning models require distributed computing to train efficiently? Welcome to our Beginner's Guide to Ray, where distributed machine learning becomes accessible and easy. This video will equip you with the skills to implement distributed ML workflows using Ray's intuitive API. From setting up your environment to optimizing hyperparameters and scaling reinforcement learning, we'll cover all the essentials you need to get started. Machine learning models have become increasingly complex and data-intensive, making traditional training methods inefficient. Distributed machine learning partitions tasks across multiple nodes, drastically reducing training time and resource consumption. Ray simplifies this by offering an intuitive API for parallel execution. Imagine training your model in a fraction of the time, while using distributed resources efficiently. We'll explore how Ray empowers you to harness distributed systems without the steep learning curve typically associated with these technologies. Ray is not just a tool but a comprehensive ecosystem designed for distributed machine learning. At its core are several libraries tailored to simplify distributed computing. Ray Core is the foundation for parallel execution, while Ray Tune facilitates hyperparameter tuning with ease. Ray RLLib supports scalable reinforcement learning, and Ray Serve enables model deployment. These libraries, with their minimalistic API, allow you to convert single-node applications to distributed ones with minimal code changes, making Ray an indispensable tool for modern ML practitioners. Setting up a distributed environment can be daunting, but Ray simplifies this process. Start by installing Ray using pip, then configure your cluster to match your computational needs. Ray's flexibility allows you to deploy on various infrastructures, from local machines to cloud-based clusters. With minimal configuration, you can optimize hardware resources, ensuring your models scale efficiently. This setup is crucial for maximizing Ray's potential, allowing you to harness the full power of distributed machine learning.
Ray Train is a key component of Ray, designed to make model training more efficient by leveraging parallel execution. By distributing your model across multiple nodes, you can significantly reduce training time. Ray Train integrates seamlessly with popular ML frameworks such as TensorFlow and PyTorch, allowing you to maintain your existing workflows while scaling them effortlessly. This block will guide you through setting up Ray Train, ensuring you can execute models in parallel, enhancing the speed and efficiency of your machine learning processes. Hyperparameter tuning is crucial for optimizing machine learning models, but it can be a tedious process. Ray Tune simplifies this by offering a powerful framework for efficient hyperparameter optimization. By integrating with existing ML workflows, Ray Tune reduces the need for trial and error, allowing you to quickly identify the best parameters for your models. This block will demonstrate how Ray Tune can help you boost model performance, streamline optimization processes, and maximize the potential of your machine learning projects. Reinforcement learning, RL, presents unique challenges, particularly when scaling complex algorithms. Ray RLLib addresses these challenges by facilitating scalable RL through distributed execution. It supports a variety of RL algorithms, enabling you to leverage the full power of distributed systems. Whether you're working on simple tasks or complex simulations, Ray RLLib provides the tools necessary to improve learning efficiency. This section explores how Ray RLLib can enhance your RL projects, making scalable reinforcement learning accessible and efficient. Even with its user-friendly design, issues can arise when using Ray. Common challenges include resource allocation, system performance, and configuration errors. Understanding these issues and knowing how to troubleshoot them is essential for maintaining smooth machine learning operations. In this block, we'll walk through effective troubleshooting techniques, helping you identify and resolve common problems to optimize your Ray environment. By mastering these skills, you can ensure efficient and uninterrupted distributed machine learning workflows. Analyzing performance improvements in real time is crucial for optimizing distributed machine learning tasks. Ray offers a comprehensive dashboard that allows you to monitor performance metrics, helping you identify bottlenecks and optimize resource allocation. By leveraging real-time analytics, you can make informed decisions to enhance the efficiency of your machine learning workflows. This section will guide you through using Ray's tools to track progress and continuously improve your system's performance.
As we conclude, remember that Ray is a powerful ally in your distributed machine learning journey. Its simplicity and efficiency transform complex tasks into manageable projects. I encourage you to explore further, engage with the Ray community, and share your experiences. Stay informed about the latest trends in machine learning and continue learning. If you found this video helpful, don't forget to like, comment, and subscribe for more content. Let us know what topics you'd like us to cover next.